So 6, we're looking at inverses. So remember, if you insert f of x into g of x, so if I have g of x, I'm going to replace x with the whole function f of x. And then we're going to do the same thing. We're going to take f of x and replace everything with g of x, every x. So I'm just going to rewrite it. And this is how we can tell if functions are inverses algebraically. So I'm going to start with this. I'm going to take the x on g of x, and this whole function is going to replace x. So I have 1 over x plus 9 minus 9. And if I simplify this, I should get just x. That's this one. That means yes. So let's see if it works. We have to simplify this fraction over fraction. So the numerator is 1. It really is a fraction though. It's 1 over 1. And the denominator is 1 over x plus 9. So to remember how to divide fractions, you take the numerator and multiply it by the reciprocal of the denominator. So sometimes we say copy, dot, flip. Maybe you've heard that before. And look what happens. We have all these 1s. So I'm left with 1 times x plus 9, which is just x plus 9, over 1 times 1, which is 1. And I don't even need that anymore. I'm just left with x plus 9, and then this minus 9. And 9 minus 9 is 0, and we're left with just x. That's what we wanted. So now we're going to go the other way. Now I'm going to take the x and f of x and replace that with the whole function g of x. So that x plus 9, now I have 1 over x plus 9. Oh, hold on. I was writing it correctly. Minus 9, and then here's this plus 9. So we need to simplify that and see if we get just x. So 9 minus 9 is 0. I'm left with 1 divided by 1 over x. And we're going to do the same thing here. I'm going to change this 1 into a fraction, so 1 over 1, and multiply by the reciprocal on the bottom. So 1 times x is x, 1 times 1 is 1, which leaves just x. So because both of those equal x, they are inverse functions.